All right, let's jump right into this explainer because today we're looking at what might honestly be the greatest cosmic plot twist in astronomical history. We're calling it the Pluto paradox. We're going to uncover how a simple, everyday math mistake led to the discovery of our solar system's famous ninth planet, and why, based strictly on cold, hard data, the scientific community ultimately had to kick it out of the planetary club. Let's journey out to the edge of our solar system. We're going to unravel this whole thing like a cosmic detective story. And the puzzle that kicked everything off was actually this. If Pluto is so incredibly small, what on Earth, or, well, what in space, was disturbing Uranus? Our story actually starts about 150 years before anyone even knew Pluto existed, with a massive mystery about wobbling planets that completely defied Isaac Newton's laws of gravity. So picture this. It's 1781 and we've just found Uranus, but astronomers quickly realized its orbit was kind of flawed. It was wobbling. They assumed another unseen planet was pulling on it, so they crunched the numbers, looked exactly where the math pointed, and boom, in 1846, they discover Neptune. It was a massive win for science, but the mystery didn't end there. Even after accounting for Neptune, Uranus was still wobbling. The orbital math simply didn't add up, which led astronomers to believe there was a massive planet X out there, pulling them off course. Now, the hunt for this mysterious planet X became an absolute obsession. It consumed brilliant astronomers like Percival Lowell, who literally built an entire observatory just to find it, though he sadly passed away before he could. The monumental task eventually fell to a 23-year-old named Clyde Tombaugh in 1930. Tombaugh's job was painfully tedious. He had to painstakingly compare thousands of photographs of the night sky, hunting for just a single, tiny dot that moved against the static stars. And finally, he spotted it. And the world absolutely lost its mind. This newly discovered world was named Pluto. That was actually a really brilliant suggestion by an 11-year-old British girl who thought the Roman god of the underworld was a perfectly fitting name for such a dark, distant place. The scientific community celebrated. They'd found Planet X. But the scientific reality of this new world was about to literally shrink right before their eyes. It's really fascinating how drastically our assumptions changed here. Initially, because they couldn't see it clearly at all, astronomers just assumed Pluto was massive. I mean, surely it had to be Earth-sized to drag giant gas planets like Uranus and Neptune around, right? But as our telescopes got better over the decades, Pluto's estimated size plummeted. By 1948, it had been downgraded to just the size of Mars. And spoiler alert, it was going to get even smaller. The true revelation didn't hit until 1978, when we discovered Pluto's moon, Charon. Now, in physics, if you know the orbital speed and the distance of a moon, you can precisely calculate the mass of the planet it's orbiting. So, when astronomers finally ran those numbers using Charon's orbital data, they were completely stunned. Pluto's real weight was a shockingly tiny 0.2% of Earth's mass. Which brings us to a glaring, massive plot hole in our detective story. Think about it. If Pluto was way, way too light to pull on massive gas giants like Uranus and Neptune, what exactly was doing the pulling? For decades, this mathematical inconsistency just haunted the astronomical community. The stunning truth finally arrived in 1989. NASA's Voyager 2 probe was flying past Neptune, and as scientists were tracking the probe's speed, they made a totally mind-bending realization. Humanity hadn't missed a massive Planet X at all. We had simply miscalculated Neptune's own gravitational pull by about 0.5%. Once that tiny, little mathematical error regarding Neptune's mass was corrected, Uranus's mysterious wobble vanished completely from the equations. Poof! Gone. There never was a massive Planet X pulling on Uranus, which means Pluto's discovery wasn't the result of brilliant orbital math. It was an incredibly, unimaginably lucky mistake. We literally just happened to be looking in the right spot at exactly the right time. Now, even after that math fluke was revealed, Pluto sat safely in our textbooks as the ninth planet. But as our technology kept advancing, a crisis started brewing. In 2005, astronomers peering out into the deep solar system found Eris. And here was the huge problem. Eris was actually heavier than Pluto. This forced a really tough scientific dilemma. Do we add Eris and potentially hundreds of other newly discovered ice bodies as official planets? Or do we fundamentally rewrite the rules of what a planet actually is? To solve this neutrally and strictly scientifically, the International Astronomical Union convened in 2006. They needed to establish strict, data-driven rules for planet status, and Pluto easily passed the first two. Step 1, it absolutely orbits the Sun. Pass. Step 2, it has enough gravity to pull itself into a perfectly round shape. Pass. So far, so good, right? But this is where things completely fell apart for Pluto. Rule 3 stated a planet must have cleared its neighborhood of other debris. Because Pluto lives out in the Kuiper Belt, which is basically our solar system's icy junkyard, and because it's so incredibly small, it completely lacks the gravitational dominance to clear those millions of comets and icy rocks out of its orbital path. So it failed Rule 3. Impartially applying these newly defined scientific rules, the IAU reclassified Pluto. This wasn't some act of malice against a beloved planet. It was just objective categorization based on new data. Pluto officially became a dwarf planet. But rather than viewing this as a demotion, a lot of scientists realized this actually shifted its title from being our puniest planet to being the undeniable, undisputed king of the Kuiper Belt. And Pluto's story was far from over. To uncover the hidden secrets of this distant king, NASA launched the ambitious New Horizons mission in 2006. This was essentially a piano-sized robotic probe strapped to the top of a mighty Atlas V rocket and tasked with traveling further than we had ever actively sent a spacecraft to intercept a specific target. Just to help you grasp the sheer, terrifying power of this mission's launch, consider the number 9. New Horizons was moving so fast off the launch pad that it passed the orbit of our moon in just 9 hours. That exact same trip, it took the Apollo astronauts 3 entire days. But even moving at those blistering speeds, space is just unimaginably vast. After using Jupiter's immense gravity for a slingshot speed boost and traveling for over 8 more years across 3 billion kilometers of empty, freezing space, humanity finally got its first high-definition look at this misunderstood world in the summer of 2015. And what New Horizons sent back? It completely broke everything we thought we knew. The first shock was its relationship with its moon, Charon. See, unlike Earth, where the moon orbits a relatively still planet, Pluto and Charon are roughly similar in size. They are perfectly tidally locked, meaning they always face each other, and they do this bizarre dance around a shifting, invisible center of gravity floating out in the empty space between them. It's wild to see. And the visuals. Oh man! Scientists were fully expecting to find a boring, dead, heavily cratered gray rock just sitting out there in the deep freeze of space. Instead, Pluto was brilliantly, stunningly colorful. The surface was this complex, beautiful tapestry of vibrant blues, deep reds, blinding whites, and bright oranges. The absolute, undeniable star of this visual show was Sputnik Planitia. This is a massive, naturally occurring, heart-shaped glacier spanning right across the planet's surface. And what shocked geologists the most was that this giant heart was perfectly pristine. There wasn't a single asteroid crater to be found on it, which in space terms means the surface is incredibly young and actively changing. So you're probably wondering, how is an active surface even possible at negative 290 degrees Celsius? Well, this heart is made entirely of frozen nitrogen. Because Pluto still has a warm inner core, that heat actually melts the nitrogen ice from below. The semi-liquid nitrogen rises to the surface, cools, and refreezes in this constant cycle of convection. It is literally constantly refreshing and repaving its own surface. We also finally learned the origin of those beautiful colors. Pluto's vibrant red and orange hues come from something called tholins. Essentially, this is an organic chemical snow created way high up when the sun's faint UV light interacts with Pluto's surprisingly complex, thin atmosphere of methane and nitrogen, which then rains this reddish dust down onto the ice below. But wait, the most mind-blowing discovery of all? New Horizons found active ice volcanoes. Instead of erupting molten lava rock, these cryovolcanoes spew freezing slush made of water, methane, and ammonia. The very existence of these ice volcanoes heavily suggests that massive, liquid water oceans might actually be hiding just beneath Pluto's thick, icy crust right now. So at the end of the day, does the label really matter? This incredible, decades-long journey proves that whether you rigidly classify it as our 9th planet based on tradition or as a dwarf planet based on precise orbital mechanics, Pluto's breathtaking, active geological complexity simply doesn't care about our human labels. It is, without a doubt, a masterpiece of the cosmos. As we wrap up this explainer, the story of Pluto leaves us with one incredibly thrilling thought to ponder. If a simple mathematical error led us to a place this dynamic, this colorful, and this geologically alive, what other vibrant living worlds are hiding out there in the darkest edges of space, just waiting for us to make another brilliant mistake? Thanks for joining us, and keep exploring.